School of Management Studies IGNOU presents an audiobook on the course MMPC 008 Information Systems for Managers for MBA program. Block 4 Support Systems for Management Decisions. Unit 12 Database Resource Management. Part 2.
Data modeling. We have discussed earlier that an organization needs to store data to process and have the desired information, and this is done through database. Data models refer to different views of data and the underlying relationships among them. Data modeling is the process of creating a data model for an information system. It gives a visual representation of either a whole information system or parts of it. It shows connection between data points. It illustrates the types of data used and stored within the system, the relationships among these data types, the ways the data can be grouped and organized, and its formats and attributes. This process is used to define and analyze data requirements needed to support the business processes within the scope of corresponding information system in organizations. Data models are built around business needs. Rules and requirements are defined upfront through feedback from business stakeholders so that they can be incorporated into the design of a new system or adapted in the existing one. The process begins by collecting information about business requirements from stakeholders and end users. Business rules are then translated into data structures to formulate a concrete database design. A data model can be compared to a roadmap, an architect's blueprint, or any formal diagram that facilitates a deeper understanding of what is being designed. Data modeling techniques and methodologies are used to model data in a standard, consistent, predictable manner in order to manage it as a resource. Data modeling makes it easier for developers, data architects, business analysts, and other stakeholders like program testers, manual writers, IT package selectors, engineers, managers, related organizations, and clients to view and understand relationships among the data in a database or data warehouse. Further benefits are that it can reduce errors in software and database development, increase consistency in documentation and system design across the enterprise, improve application and database performance, ease data mapping throughout the organization, improve communication between developers and business intelligence teams, ease and speed the process of database design at the conceptual, logical, and physical levels, help manage data as a resource, be used to integrate information systems, be used in design of data warehouses and data repositories. Data models can generally be divided into three categories. The process starts with a conceptual model, progresses to a logical model, and concludes with a physical model. The three data models are as below. Conceptual data models. They provide view of what the system will contain, how it will be organized, and which business rules are involved. Conceptual models are usually created as part of the process of gathering initial project requirements. Typically, they include entity classes, their characteristics and constraints, the relationship between them, and relevant security and data integrity requirements. Logical data models. They provide greater detail about the concepts and relationships in the domain under consideration. They indicate data attributes such as data types and their corresponding lengths and show the relationship among entities. Logical data models don't specify any technical system requirements like storage requirements, etc. Physical data models. They provide a schema for how the data will be physically stored within a database. As such, they are the least abstract of all. They offer a finalized design that can be implemented as a relational database, including associated tables that illustrate the relationships among entities as well as the primary keys and foreign keys that will be used to maintain those relationships. Physical data models can include database management system, specific properties, including performance tuning. Numerous commercial and open source computer-aided software engineering case solutions are widely used today, including multiple data modeling, diagramming, and visualization tools. Some examples are Irwin Data Modeler, Enterprise Architect, ER, Studio, and free data modeling tools such as Open Model Sphere. All the above data models can be broadly classified into three: record-based data models, object-oriented data models, dimensional data models. The record-based data modeling has been in practice since beginning of application software development using database approach. The three submodels are hierarchical, network, and relational models as briefed below. Hierarchical models. These are the early data models used in 1970s. Hierarchical models capture the intuitive hierarchy of the data elements. The early generation of large DBMS, example IMS, Information Management System, by IBM belongs to the hierarchical data models and were widely used especially in banking. Though this approach is less efficient than more recently developed database models, it's still used in extensible markup language, XML systems, and geographic information system. Network models. Since hierarchical models are enabled to represent data items that existing at two different levels of hierarchy, network models were proposed. The notable systems built using these models were Adabas, IDMS, and DBMS 10. They were found to be more powerful and were used in various sectors like telecom, production houses, etc. Relational models. Though network models were quite powerful, they lacked in elegance and were not simple to use. DBMS with relational model is also known as RDBMS. The systems built on this data model were DBase, XBase, and Oracle. Almost all commercial systems presently available like Oracle 11G, Oracle 12c, Oracle 18c, and the latest as of now, Oracle 19c, SQL Server, MySQL are built on the relational models. Data modeling in RDBMS is achieved in two levels. 1. ER modeling that builds the entities and provides entity relationship diagrams. 2. Normalization, which removes the redundancies. Object-oriented data models came into practice because of object-oriented programming, and it became popular in the mid-1990s. The objects involved are abstractions of real-world entities. Objects are grouped in class hierarchies and have associated features. Object-oriented databases can incorporate tables but can also support more complex data relationships. This approach is mostly used in multimedia and hypertext databases. The approach is, however, not as simple as the relational data modeling, in which ER diagram very simply depicts all the entities, attributes, and relationship between entities. Object-oriented data modeling has advantage of getting more redundancies removed and hence uses less storage space as compared to ER model. Dimensional data models are designed to optimize data retrieval speeds for analytic purposes in a data warehouse. While OOD and ERD data models emphasize efficient storage, dimensional models increase redundancy in order to make it easier to locate information for reporting and retrieval. This modeling is typically used across OLAP systems. OLAP is software for performing multidimensional analysis at high speeds on large volumes of data from a data warehouse, data mart, or some other unified centralized data store. The ER data model is the most common data model, which allows us to represent the relationships among the entities. It uses following three concepts to represent itself graphically. Although we have discussed them earlier, we revisit them here once again. Entity, any real-world object that has certain properties, and this object are uniquely identified by the system on the basis of these. This is represented by a rectangle with the entity name specified in the center. Attribute. Attribute is the property of an entity. Like a student entity can have attributes such as student name, student roll number, student class, etc. Attributes are placed inside the circles and attached to the entities and relationships. Relationship. Relationship specifies the meaningful relation between two entities. This relationship can also have attributes. A rhombus represents these with a relation specified in it. For example, if we have a student and course as entities, then we can relate these entities as student enrolls for a course. Degree of relationship. This specifies the occurrence of entity with other entity, one-to-one. In this, there can be almost one related occurrence for each entity. For example, a single manager manages one department and one department can be managed by a single manager. One-to-many. Here, for one occurrence of the first entity, there may exist many occurrences of the second entity, and for every occurrence of the second entity, these exists only one occurrence of the first entity. Many-to-many. In this degree of relationship, for one occurrence of the first entity, these may exist many occurrences of the second entity, and also for every occurrences of second entity, there exists many occurrences of the first entity. Normalization is another concept in data modeling. Normalization is a process of converting complex data into simpler form without any loss of information. The normalization technique ensures that there is no dependent and duplicate data when the ER model has been made. Normalization, first of all, converts the data into tables or relations. These tables are checked for redundancy. Finally, the form is converted to a database definition. Why do we need normalization? Normalization improves the database design. Whenever the design is modified, we need to reorganize the data. Normalization reduces the need of reorganizing the data. Process of normalization removes all undesirable consequences that may occur due to inserting, updating, and deleting values from the table. Normalization reduces the unnecessary repetition of data that causes the problem with storage and retrieval of data. Poorly designed databases have several data management difficulties. Example, consider a relation, library, mname, madd, btitle, isDate, dueDate. This relation has the following problems. 1. Here duplicate data exists because member address will be repeated if a member issues more than one book. 2. Insertion problems. If a member does not issue a book, then we cannot record the address of a member. Here, mname and btitle are both necessary and hence we cannot leave any one of them as blank. 3. Updating problem. If a member has issued 2 or more books, then address is necessary in all, and if a member's address needs to be updated, then all the records needs to be updated. 4. Delete anomalies. Here, if we delete the issue details, then address would not be there. But all the above problems can be eliminated by normalization. If this single relation is broken down into 2 relations, member details, mname, maddress, member trans, mname, btitle, isDate, dueDate. Both this requires a join between these 2 relationships, which is very expensive. The data is still redundant in this form. Here, combination of 2 keys, roll number and subject, is primary key. Roll number and subject determines marks. Roll number determines name. Name has no dependency on the attribute subject. This may lead to following problems. Insertion. The name of a subject cannot be recorded until a student gives any exam. Updation. Roll number and name is repeated several times. If name of the student is to be changed, then at every place the name needs to be updated, otherwise may lead to inconsistencies. Deletion. If a student has not given any of the 3 exams, then the name of that particular student will be deleted. So, for overcoming these problems, this first normal form needs to be decomposed and converted into second normal form without any loss of information. A relation is said to be in 2NF only if it is in 1NF and every attribute dependent on the whole key and not just a part of it. Other major normal forms are 3NF, BCNF, and 4NF. Third normal form or 3NF is used to prevent loss of information and dependencies preserving decomposition. BCNF is the advanced version of 3NF. It is stricter than 3NF. Fourth normal form or 4NF is used to preserve multi-value dependency, which is essentially a constraint. There are several other normal forms like project join NF, domain key NF. We are not describing them as it is not within the scope of this course. Attributes in tables. In ER model, each entity and relation has a corresponding table. For storing the data in a database system, each column in the table have a certain type of data. For example, when we create a table for employees' personal data, then we may have different fields like name, address, phone, age, etc. In this, if we take the attribute name, then this would be of character type and age and phone are of numeric type. Sometimes an attribute of table T takes the value from a set D that is known as domain. A domain is defined in the cases when we want an attribute to take some exact set of constants. For instance, the domain of the attribute age for a particular post that a candidate can apply for might be defined as consisting of all the integer numbers between 18 and 25. On the other hand, the domain of the marks column might be defined as all the numbers between 0 and 100, with at most one non-zero digit after the decimal point. The significance of declaring a column of a table to have a particular type is the ability to compare the values of two different column rests on this declaration. A particular column in a table must contain similar data, which is of a particular type. Besides storing character, numeric, we can also store data such as graphics, sound, etc. Whenever we have the biodata of the employees or students or candidates, generally we store their photographs. In other applications like for passport or in Aadhaar, PAN or ATM card, etc., biometrics is essentially used. In such cases, we can use graphics as a data type for photograph and biometrics column. Developments in database technology. DBMS consists of a collection of interrelated data that is called a database and a collection of programs to manage and access the data. An RDBMS is a collection of tables, each of which is assigned a unique name. Each table consists of a set of fields and stores a large set of records. A data warehouse is a repository of data collected from multiple sources stored under a unified schema that resides at a single site. There have been a lot of developments in the field of database technology. These developments include handling of spatial data such as maps, engineering designing data such as design of buildings, components, and circuits, multimedia data such as text, image, video, and audio data, time-related data such as historical records or stock exchange data, and the World Wide Web data. Han and Camber had described each of these advanced databases. Object-oriented databases. In object-oriented databases, each entity is considered as an object. These objects can be customers, suppliers, employees, or items. Objects that share a common set of properties can be grouped into a class that represents properties common to the class. Object relational database. In object relational database model, much is the same as the basic relational data model, but for the fact that object relational database also handles complex data types and complex object structures. Spatial databases. These databases contain geographic databases, clip design databases, medical and satellite image databases. These data are represented in raster format, consisting of n-dimensional bitmaps or pixel maps as well as vector format, consisting of basic geometric shapes such as points, lines, and polygon, etc. Time series and temporal database. These databases contain time-related data. A temporal database usually stores relational data that include time-related attributes. A time series database stores sequences of values that change with time. Text and multimedia databases. Text databases contain word description for objects. Multimedia databases store images, audio, and video data. These databases are used in applications such as picture content-based retrieval, voicemail systems, video on-demand system, and World Wide Web, etc. Heterogeneous databases. Objects in one component database may differ greatly from objects in other component databases making it difficult to assimilate their semantics into the overall heterogeneous database. There are special methods for analysis of such databases. World Wide Web databases. World Wide Web has data objects linked together to facilitate interactive access. Users seeking information of interest traverse from one object via links to another. These databases are also called as virtual databases. It is mostly used by organizations for gathering secondary data for business analysis. Database administrator and the role. Large and complex databases need a lot of maintenance to work in a proper manner. A database administrator does this maintenance. DBA is the supervisor of the database and hence have the highest level of expertise. DBA centrally controls the database and administers the overall user community. Database administrator, DBA, also takes care of the data and controls the database structures. DBA is responsible for accessing the database so that an unauthorized person should not access the database. DBA stores the permissions granted to the users created to verify that a particular user can only perform a given operation on the database. DBA can also revoke the permission if he finds that the user or user group needs no more access to that particular portion of the database. DBA account is sometimes known as the system account that has the powerful capabilities that other regular database users don't have. Sometimes, when more than one user uses the same resource, such as the data, there may exist the conflict, but the DBA seeks for the compromise and takes care of the conflict for the benefit of the organization. Hence, DBA also has the responsibility for maintaining the integrity of data. This means that only accurate data can be inserted into the database. Duties of DBA include the existing control, definition control, quality control, update control, access control, storage control, etc. The DBA is also responsible for recovering the database from failures that may be due to human disasters, software and hardware causes, or natural causes with the minimal loss of data. DBA changes the database according to the changes or growth in the organization. Hence, DBA is said to be a super user who is responsible for monitoring and improving the performance and operations to maintain the database activities. The database dictionary is one of the most important tools for the database administrator. It is used to maintain information related to various resources. It contains metadata, that is, data about data of all applications running on single or multiple servers. Database and data warehousing. Database is collection of data on a subject. The word data warehouse was first introduced by Bill Inman in 1990. According to him, a warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. You will read in detail about data warehousing in the next unit. A data warehouse is a central repository for significant pieces of the data that are collected by various business systems. Data from various online transaction processing applications and other sources is organized on the data warehouse for use decision-making process. A data warehouse is used in applications like data mining, web mining, and a decision support system. Data warehouse enables the executive, manager, or the analyst to make better and faster decisions. It presents the right information in the right place at the right time with the right cost in order to support the right decision. According to Inman, a data warehouse should firstly have a common format, meaning that data that goes into a warehouse should have a common data format. Since a data warehouse is made out of a combination of various organizational databases of the company, every care should be taken to maintain uniformity. Secondly, since different company functions such as sales, marketing, HR, finance, and production have some variables common in a database, a data warehouse should be able to use these data pertaining to different functions. Thirdly, since data often contain time as a dimension and is updated into a data warehouse periodically. A data warehouse should be efficient in computing all time-dependent aggregations again and again. Finally, since data warehouses are never deleted or updated, they should be able to sustain large chunks of data. A data warehouse grows all the time as new data keeps on adding. In practice, a data warehouse is often resynchronized to keep its volume manageable. Resynchronization means that data is kept in periods and as and when a new period is added, the oldest one is deleted. There are some very preliminary concepts about data warehousing. You will read about it in more detail in the next unit. Summary. Data consists of fact and detail about things, activities, transactions, etc. Data can be stored as a resource that can be drawn later on to produce information for the people and activities that need it. In this unit, we have discussed about the prominent features of a modern database management system. Understanding a DBMS is very significant for a manager dealing with information systems. You have learned about modeling data and different data types. You saw the developments in the field of database technology. This shows that almost any kind of data can be handled, be it a music database or a database of photographs stored on the computer. The unit closes with giving you a glimpse of success factors in data warehousing, which you would read in detail in the next unit. We have limited our scope in the sense that we would not like to make you a programming expert, but would be more interested in making you to capable of applying these concepts for deriving business advantage.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code MMPC 008, Information Systems for Managers. Course coordinator, Professor Anurag Saxena, School of Management Studies IGNOU. Voiceover by Renuka. Edited by Uday Sharma. Program assisted by Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.